So again, good morning, everyone. Thank you very much for joining to our departmental showcase for the Center for Applied Data Science, or we call it CADS at WSSU. So this is a relatively very new center, only started its activities since last July, but basically we kind of like are on the foot, are running our activities since last September, I would say. So we received a substantial funding from UNC ROI, and the goal is to establish a center that is going to apply the data science in the interdisciplinary fields. So our center's main goal is to do interdisciplinary research. So basically, we are interested in applying the data science, okay, and then finding the patterns or predictive analysis in the other fields rather than the computer science. So we are a collaboration between the computer science and statistician with the other sectors to solve the important problems in the other sectors that do need the data. So we do have a packed schedule today. So we are going to hear from our student researchers. There are 8 of them who has been working diligently for the last few months on achieving their research goals. So as you can see, each of them is going to present in various projects. We also have with us wonderful faculty fellows who are the researchers that are actually mentoring those students and getting the goals of the centers done. So we do have Dr. Steve Aragon from the healthcare management, with us, Dr. Mustafa Fuad from computer science, Dr. Russell Smith from geography, Dr. Jill Keith from biochemistry, and I think we are missing Dr. Presley, who is also from chemistry. So these are our research faculty fellows. I would also like to acknowledge our wonderful research associate who has been also mentoring and guiding students for the past few months to prepare them for this presentation. We do have Dr. William Nick as our postdoctoral research associate and Mr. Peter Ewan as our research associate as well. I believe we also have our wonderful admin, Ms. Rochelle Blakeney with us. So I would like to acknowledge each and every one of you for your hard work and to make this team such a accomplished one. So without further ado, I would like to start the presentation. So just to make the time more efficient, we recorded the presentation, and I'm going to play the recorded presentation from my side. However, after each presentation, the students will be able to answer any question that you have. So we would like to have this one as much as interactive as possible. So please, ask the students if there is any question that you are having about the, projects. So without further ado, let's start with the first project, which is going to be presented by Hector Santiago and Gary Myers.
Hello, everyone. My name is Hector Santiago. I'm a CADS research assistant and a CS major at Winston-Salem State University.
It's Gary Myers. I'm a CADS research assistant and information technology major at Winston-Salem State University.
And our faculty mentor is Dr. Debzani Deb. She is the founding director of CADS at Winston-Salem State University. And this is a presentation on the analysis of COVID-19 data for the state of North Carolina. So the goal of this project was to show and to try and predict the impact that COVID-19 would have on North Carolina as a whole, as well as 6 specific counties in the vicinity of Winston-Salem State University. Those focus counties are Davidson County, Davie County, Forsyth County, which is where Winston-Salem State resides, Guilford County, Stokes County, and Yadkin County. As well as try and draw correlations between key factors in people's lives, such as employment status and susceptibility to contracting COVID-19. And what our data shows, where we utilized data from usfacts.org, and the data sets contain daily county level tracker of COVID-19 cases. This makes it easy to follow COVID-19 cases on a granular level, as does the ability to break down infections per 100,000 people within the data. The underlying data is available for download from their website. And this data has actually helped government agencies like the CDC in its nationwide efforts in combating COVID-19. We also utilize data from data.census.gov. This gave us demographic information for each county in the United States, which we combined with the COVID-19 data set to get the socioeconomic factors breakdown. Okay. And one of the things that we wanted to show were some trends and to try and represent what the data is telling us. So what we can see from here is that we have some high peaks. And as you can see in the top graph here, there's Forsyth County in green. And we could see that Forsyth County had the highest single day death counts out of the 6 counties. And down here in the cases graph, we could see that Guilford here in red had the highest single day positive case count of the 6 counties. So Forsyth had the highest death count and Guilford had the highest case count in one day. Another thing that we could see from this graph here in the bottom is that cases have decreased dramatically since January 2021. And this is possible due to new vaccine availability or other factors that have been put into place to combat COVID-19 since then. And so to continue with our trends, one thing that we were able to see is that although the population for each county is different, the case rate and the death rate were nearly similar between them. We could see that each county followed the trend of the entire state of North Carolina. And we could only see slight differences from the mean, which shows that Yadkin County had the highest infected rate and that Stokes County had the highest death rate. And another thing that we wanted to try and do with this project was to try and make predictions. So we could see up top here that Forsyth County's cases will continue to decrease and plateau some based on the prediction and based on the current data that we worked on to make this prediction. The cases should continue to drop from here on out. So that's very promising for many people looking to get back to work or to get back on campus and have some sort of life like it was pre-COVID.
Socioeconomic factors, we observed some patterns between demographic variables. Some of the factors were employment percentages of a population of 16 years and over who had an occupation that involved either sales or office. And we had some questions. Is a person's employment status likely to be susceptible of contracting COVID? Does family income has an effect on whether they're possible of contracting COVID? And health insurance coverage, is someone who's on private health insurance is less likely to contract COVID-19? As we did this project, we observed some correlations. Some were positive, some were negative. Employment status of 16 years and older had a positive correlation of 0.8732. That's an approximation. Families whose income fell between 50,000 and 75,000 had a negative correlation of 0.6629. And the percentage of the population who had private health insurance had a positive correlation of 0.406328. Now, as we look at this graph here, we can see a visual representation of the correlation we have here with the 16 years and older who have occupation and sales in office. The red line represents the case rate. The blue line represents the variable we are observing. As the red line moves, the blue line follows it, which represents a positive correlation. And a person's employment status does make them more susceptible to catching COVID because they are doing and interacting with other individuals. Families who have income in between 50,000 to 75,000. This graph is a representation of a negative correlation. It doesn't really follow the red line, that is the case rate. The blue line does the exact opposite of what the red line does. Usually families that fall in this category are employed, which means they are at higher risk of catching COVID-19 depending on their work environment. Percentage of population who have private health insurance. This is a positive correlation. Once the lines are pretty steady with each other until the very end, and then it follows a little bit at the end also, or it starts kicking back up. People who have private health insurance are less likely to catch COVID because people who are insured are less likely to die because they have the financial support for medical emergencies.
And so just a little bit on what we learned throughout this project. One of the major things that we can see is that obviously COVID-19 has had a huge impact on these 6 focus counties, North Carolina as a whole. The 6 counties that have had a lot of cases and deaths caused by COVID-19, with Yadkin County having the highest infected rate again, and Stokes County having the highest death rate. These predictions that were made based on the current data for these counties show us that cases and deaths should continue to drop. And hopefully with continued use of masks, social distancing, and vaccinations, that will help us continue that path to getting to pre-COVID, to life pre-COVID. As well as another thing that we were able to learn is that a person's socioeconomic status can have a major impact and effects on their chances of contracting COVID-19. So that's a major key that we were able to find with this project as well.
Acknowledgements. This research was supported by the UNC Research Opportunity Initiative Award granted to Win Southern State University Center for Applied Data Science.
And thank you for your time.
So I think we are running a little bit late, but we still can take 1 or 2 questions from the audience if you have any for Hector and Gary. They are also available to take your question.
Great job, Hector and Gary. I have no questions.
Thank you.
Yeah, I have a quick question. How big was the data set? Like how many?
It was really big. It had a tremendous amount of variables because it had cases from all the counties, and it was
so basically, yeah, we had like a nationwide data set, and that contained a FIPS code per county, and it was broken down for these specific 6 focus counties. So we sort of broke the big file down into a smaller one and got data all the way back from like March 2020 up to, like March 2021, April 2021, to present the data.
Good, thanks.
Thank you, Dr. Fuad. Thank you, Dr. Aragon. So we are going to move to the next presentation, who is going to be presented by Meg Podol, and his faculty mentor is Dr. Russell Smith.
Hi, this is Raj Podol, CADS Research Assistant, undergraduate, computer science major, Winston-Salem State University. Today, I'm going to present a research which was recently conducted by our mentors, Dr. Russell Smith, Professor of Geography, Winston-Salem State University, also faculty lead for the Special Justice Studio, and Dr. Devjani Dev, Associate Professor of Computer Science, Winston-Salem State University, also founding director of Center for Applied Data Science. And let me go to the next slides. So here I'm going to introduce about a little bit about our project. So the special justice is all about our special justice and injustice. So special justice is actually equitable and fair distribution of all available resources across a variety of geographic landscapes. So Rocco says, special justice refers to general access to public goods, basic services, cultural goods, economic opportunity, and healthy environments. So this research finds out the issues of special justice through the development of special justice index. To date, most of the works about this special justice industries have been quantitative and case study based. But here, this research is trying to explore something quantitative solutions, exploring geographic attributes like land uses, distance to parks, schools, etc. of census tracts in an effort to apply the concept of these special justice industries to all NC communities. And data set and methodology, like here in our research, we identified and collected 28 geographic and special features across 2,194 North Carolina census tracts, which was identified by the US Census Bureau. And those special features are gas station, fire stations, area covered, emergency facilities, likewise, all the way to pharmacies, job density, total jobs. Altogether, there are 28. And in this research, 5 regression models have been built, which are economic mobility, which you can see in the figure alongside, economic mobility, dissimilarity index, social vulnerability index, sprawl index, housing and transportation index. So using these 5 dependent variables, the relationship between each of these 5 models and those 28 special features have been captured, and based on the results and the statistical significance features, the most correlated set of those features have been identified, which are described in the next slides. So from the research, we have found that the sprawl index model has been the most accurate with 95.3%, which have been highlighted here in the figure. And this is followed by another regression model, which is housing and transportation index with an accuracy of 94.5%. And similarly, the important features have been identified using those 5 regression models and add the significance level of 0.05 level across at least 3 of these 5 regression models. The important and significant special features have been identified. Like here, you can see the food desert has been found 5 of 5 across these 5 regression models at 0.05 levels. And the next one is mean commute time, which is also 5 out of 5 across these 5 regression models. And similarly, we have other important and significant features identified, like you can see, like this medical facility is 4 out of 5, law enforcement is 3 out of 5, gas station is 4 out of 5, and similarly, the other features can be studied from the figures. And finally, about our research, we hope that these findings to develop the social justice index can be applied across the entire country to help communities understand, accept, and potentially fight special unjust geographies within their communities. And this is the conclusion of my presentations. And these are the references I have used. And thank you so much.
So Meg can take some question if you have any.
Raj, your work is very interesting and it's very important. And I was just wondering, when you talk about a social justice index, do you have in mind, you've been measuring what an actual index is. Do you have an ideal index in mind that should be achieved? A targeted index versus what the actual index is?
So I can repeat the question. I didn't get the question. Like in the project, like we selected 28 geographic and spatial related features. And your question, like, can you repeat the question again?
Okay. Did you come up with an index, one index that indicates that measures social justice? Or
I think that regarding the social justice,
that,
like,
are you asking what would be ideal for the community to ensure that there's social justice?
yes, I'm asking.
Equity amongst the neighborhoods?
Yes.
Yeah, I think in our 28 features, something related to social justice.
Can you show the other slide that had the tables?
Give me 1 second.
We can go on with this. It's a little bit more complex question. I was just curious if you came up with one social index and then based on the actual data, and then how does that compare to what you would think an ideal index would be? For example, if you, and I see the R-square values here very high for the highlighted models. I was just curious. I was looking for one index.
Yeah, I got your question now. Yeah, so among those 28 features, like here, we only targeted like at 0.05 level, at least across 3 of those models, right? So
Yeah.
from them, we have found like medical facility, law enforcement, gas station, food desert, limited broadband, pharmacy, non-public school, mean commute time, total jobs, area covered, underground tank, and brownfield, right? These are like at least across 3 labels. And like the social, like the features that you're talking about should be less than at least 3 across these models. So that's why we didn't select that here. So we only focused at least three of those features which appeared at 0.05 level across these 5 regression models.
So it looks like, even though it's in yellow, it's hard to see. Is that
yeah, the first one is food desert.
Food desert. So yeah, food desert. So it looks like if you tackle the poverty, right, and food desert and the mean time, so ability for people to get to and from work. Looks like tackling those 2 things would be helpful. Is that what we should be taking away from that?
Exactly, yeah. So these 2 features have been like identified as very significant because these are at 0.05 level. These have been appeared, right, like across those 5 regression models. So from this, we can conclude like these are the very important features that could like facilitate or help to decide like the social justice, special justice or injustice across the communities.
Thank you very much, Raj. I am, sorry to interrupt, but we need to move on with our next presentation.
Okay,
It's a
thank
very,
you.
very exciting topic, and I'm sure Dr. Smith also has a lot to add on to that. So yeah, we can definitely discuss outside, the presentation for that. But now our next presenter is going to be Dr. Kaya Prost, and her faculty mentor is Dr. Steve Aragon. And I would like to, stop sharing so that Dr. Prost can share her screen. Dr. Prost, are you ready?
Yes, I'm just sharing my screen.
Mhm.
We good to go?
Yes.
All right. So good morning, everybody. Once again, I am Dr. Kaya Probst, and I am a graduate student in the Master of Healthcare Administration program. I'm a second year grad student, so we'll be graduating in May. And my faculty mentor, as she said, is Dr. Stephen Aragon, and it has been a pleasure with working with him. This has also been a team effort with other authors as well, Dr. Boykin, Dr. Laura McGuinn, and Sabina Gazelle. And today I will be speaking about the influence of physician-patient centeredness on the African-American male cardiology patient's experience of care. So when we're looking at this primary provider theory, we must first take note that the guiding principle of the primary provider theory states that above all else, it is the ethical responsibility of the physician or healthcare provider to protect the best interest of their patients. As shown on this model, the patient-centeredness of the provider has an absolute effect on the patient's experience of care. In addition, the patient-centeredness of the provider also has an indirect effect on the patient's experience of care through the patient-centeredness of waiting and the patient-centeredness of their associates. So our research seeks to answer the following questions. Does cardiologist patient-centeredness affect African-American male cardiologist patients' experience of care? And if so, how much? Is the effect stable across various random samples? Does the hypothesized model hold against a rival or competing model? And are the results consistent with the prediction of the primary provider theory, as we just saw in the previous slide? So our sample consisted of 840 African-American male cardiology patients across 3 sample groups. And these patients were from a national inpatient database, is where we got our patients from. So our hypotheses are as follows. The model should be consistent with patients' real-world experience of care. As well as physician-patient centeredness will have an effect on the patient's experience of care. It will also have an effect on the actual physician's concern for patients' questions or worries. Also, how well the physician is able to keep the patient informed, and how friendly and courteous, the physician is. As well as the patient's experience of care will then in turn also have an effect on their likelihood of recommending the hospital, as well as their overall rating of care given. So our measures, as seen here, all measures are highly reliable and valid, as seen with 0.97 and 0.96 reliability scores respectively. And each measure includes these observed variables, as we just mentioned. So for our results, the model fits, as seen with the physician-patient centeredness significantly influences the patient's experience of care, and your physician-patient centeredness explains 63% of their experience of care. Once again, the effect of physician-patient centeredness was stable across all samples, all of the 3 samples, and the patient-centeredness model held versus a competing model as well. The total standardized effect just shows that the patient-centeredness of the cardiologist had a significant effect on patients' experience of care and measured outcomes at 0.79, 0.72, and 0.75 respectively. So just to conclude, explaining 63% of variability, cardiologist patient-centeredness significantly affects the African-American male cardiology patient's experience of care, their likelihood to recommend the hospital, as well as the overall rating they would give to their care. And once again, at 0.79, 0.72, and 0.75 standard units. These effects were stable across the 3 national random samples and the hypothesized model held against a competing model. And lastly, these results were also consistent with the predictions of the primary provider theory as I described before. So a little bit of discussion given a personal perspective. Here we have a patient, a 62-year-old African-American male. He presented with symptoms of shortness of breath on exertion, only symptom that was present. The diagnosis that this patient received was idiopathic congestive heart failure. And if you're not familiar with idiopathic, it just means that cause is unknown. A little bit of the patient's history. Patient was a non-smoker, consumed just the standard American diet, had no previously known chronic conditions, received yearly physical exams, and was a moderately active person prior to diagnosis. Treatment with the cardiologist included 5 prescription medications, including atorvastatin, carvedilol, Bidil, Entresto, and spironolactone. So let's look at patient-centeredness with the interaction with this cardiologist. This cardiologist lacked patient-centeredness in the following ways. The cardiologist was unable to establish trust with the patient or family, failed to address any of the patient's concerns, as well as dismissed questions, and was unwilling to answer questions from family members as well. The outcome of this interaction was that the patient terminated that relationship with the non-patient-centered cardiologist and switched to a more patient-centered cardiologist. And that switch resulted in a more positive experience of care. And one thing to note is this personal experience is one that I have a firsthand view of, because this patient is my father. My father was diagnosed with congestive heart failure and no previously known conditions, very healthy. And when you get diagnosed with an idiopathic anything, you really have a lot of questions and you desire answers. And the sentiment from the cardiologist was, I am the cardiologist, I know, and so just listen to what I say. And so any questions that was posed by myself, because I was also present at that initial meeting with the cardiologist as well, were dismissed as my father was just simply told that these medications are the only thing that's going to help you, and this is what you're going to have to do for the rest of your life. So looking at the conclusions on how patient-centered, the patient-centeredness of the physician has an effect on the patient's experience of care, that model absolutely holds true, because I do have a personal experience with that. And with that, I would like to just thank everybody for their time and attention today in my presentation and hearing my story, as well as I would like to acknowledge all the kind of folks that are in support of this research. Thank you again.
Thank you, Dr. Prost. We probably can take only one question because we are running a little bit late over here. If there is any quick question.
I have a quick question. So
Mhm.
are hospitals rated according to patient-centeredness when they rank and say the best hospitals for cardiology, so to speak?
So hospitals can, simply give patients like satisfaction surveys or things like this. And what this model does is take into account any way that the patient was surveyed, whether it was on a scale of 1 to 5 or a scale of 1 to 10, no matter how the patient was surveyed based on their experience of care, it takes in all that into account.
Just to quickly add to that, Dr. Keith, yes, all hospitals are measured on the basis of patients' judgments about their experience of care now under a new federal policy that was issued in by the Accountable Care Act. The policy is called the Value-Based Purchasing Program. So hospitals are measured on their quality outcomes, their patient-centeredness, safety, and effectiveness. All weighted equally, by the way, 25%, 24% each, 25% each.
Thank you, Dr. Agron. I'm sorry. Again, we are running late. I would love to continue this discussion, but again, we can take the discussion after the, the presentation, if we would like to. But let's just start the next presenter over here, who is John Milton, who is a graduate student in the computer science department, and he is actually doing his master's thesis based on this project. So,
hello everyone. My name is John Milton, and I'm a computer science graduate.
To share the video.
I will be presenting my talk to the title, Exploring the Impact of Inner Social Networking Factors on Cognitive Aging through Predictive Analysis. This work was supervised by one of our research associates, Dr. William Nick, and my faculty mentor, Dr. Debzani Deb. As research has showed that as adults get older, their cognition tends to decline, and that can really cause a big disruption in their social activities. The early warning signs of these disruptions can include the loss of community connections and also a change in interaction with their family and friends. And these social function changes in these adults can affect their quality of life, which can provide impediments for independent living and increase mortality. So the rest of my talk will go as follows. I will talk about the 4 algorithms that we use for our predictive analysis, and they are as follows: linear regression, k-nearest neighbor, decision tree, with random forest, and our approach, results, and conclusion. So we built our first model using the multivariate linear regression, which is a type of regression, analysis where there are many independent variables, and that is why it's called multivariate. Also, there is a linear relationship between the independent variable x and dependent variable Y. Our next model was the KNN, where this algorithm belongs to the class of supervised machine learning techniques, mostly for density estimation. So KNN, it calculates the distance between similar points. In other words, it assumes that similar things are near to each other. So just think about it. Just think about the general saying that goes like this. Birds of the same feather flock together. So pretty much that is how that sounds to me. And next, after carrying the distance, it selects the specified number of points that are points closest to like the current data points. Then do a vote for the most frequent label. Our third model was decision tree. And how this model works is by splitting its roots node into subsets based on a set of rules. And this process is continued recursively until the subset reaches the target value, where the node can no longer be divided into subsets anymore. And once it hits that point, then the decision tree is built, and we can use it to find the classification on an input by comparing the values on the edges of the node, and then makes its decision on what path to take. Okay. So our next is random forest. So a random forest is pretty much similar. It's pretty much similar to the decision tree. And the difference with the random forest is after a number of user-specified trees are created, but the process is the process of creating this specified these trees. For a random forest, it does that randomly for each with the same depth. And it uses the training data set to fill in the leaves for these to fill in the leaves for this model, and it forms a group of machines of sorts, like a group of machines to create a classifier. For our approach, we used a population-based study of health, social life, and well-being among aging Americans, called National Social Life and Healthy Aging Study, which is the NSHAP. So this study collected data on a nationally representative sample of community dwelling individuals between the age of 57 to 85. And these individuals are sometimes called senior citizens. So after a good analysis of the data, we decided to reduce to 32 variables for our experiment, which we thought were closely connected to close or inner social network health. While processing the data, there were missing values found in the ethnic group column. Our approach to that was to substitute each missing values with the mean value of that column using the inbuilt Python mean value function. Another column had categorical data, which is not appropriate for our model. Our approach to that also was to encode it using the one-hot encode method that makes the data suitable for our model after it was encoded. So while building our model, we realized in order to avoid overfitting, we decided to randomly split our data into two sets, 80 for training and 20 for testing. And after building our model, we used the root mean square error to measure the accuracy of our model. And here was our result. So as you can see, the random forest performs the best with the least error, 3.27, and the decision tree performs the worst. Next to the random forest is the linear regression with a 3.28 and followed by the k-nearest neighbor. In conclusion, our work tries to provide insight into how a person's cognitive aging may be impacted by their inner or closer social network. Also, we used a publicly available data collection that is supported by the National Institute on Aging. Then, out of our 4 models, the random forest worked the best for regressing the data. And our future work will be to investigate and finding the feature importance to identify more social features that will impact the cognitive aging. Thank you.
I think we cannot take any other question just because we are running out of time. So we are moving on with our next presentation with Anthony Smith, Timothy Bittman, and Alexis Blunt, and their mentors are Dr. Fuad, Dr. Presley, and Dr. Keith.
Hey everybody, my name is Timothy Pittman, and I'm a junior information technology major, and my mentor is Dr. Presley.
Hey, my name is Anthony Smith. I'm a junior computer science major at WSSU, and my mentor is Dr. Fuad.
Hi, my name is Alexis Blunt. I'm a senior at Winston-Salem State University. My major is biology with a minor in chemistry and public health. And my mentor is Dr. Keith.
All right, and today we will be presenting our project entitled The Impact of COVID-19 on College Students' Social Well-Being. As we all know, COVID-19 really impacted the lives of millions, especially college students. And mental health among these college students suffered as anxiety and depression increased. Many students voiced their dislike for virtual learning on social media, especially Twitter. In our project, we addressed 3 separate questions. First, what are the most talked about topics on Twitter among Winston-Salem State students? Second, what extent are WSSU students concerned about COVID? And third, does sentiment change in response to the pandemic? Our data was obtained and analyzed using a software called Discover Text. Sifters were used to find the most relevant items to our project.
Okay, so I had the first data set collected. It was collected from January 24th to 2020 to February 24th, 2021. And the data was collected using the hashtag WSSU with a keyword included, COVID-related keyword. here are some examples of the keywords that was used, and the total amount of tweets collected were 638 tweets. So this is the timeline of the data we collected. You can see it from the 1 year. You can see spikes in it, so we wanted to figure out why we thought these spikes could have occurred. And so this is some of the reasons we think the spikes may have happened. We can see August 2020, we can see returning to the fall 2020 semester. And in early October, we start to see the first quarantine of the residential halls because of COVID. And then we could see the high interest in food trucks coming every Thursday and Friday in October. And in late October, you can see Halloween events and the food.
I'm just going to interrupt. Can you see the video? Anyone, can you please confirm whether you
Yeah, yes, sure.
Yes,
Yeah, I
you
can
can
see it.
yeah.
Yes.
Yeah.
Sorry,
Yeah, I think it's in my side.
Okay.
I'm trying to, yeah.
In the November 2020, we can see block party, the food truck still, the last day of classes, including like the final exams. And then in January 2021, we see the preparation for spring 2021 semester. So this is the most used single keyword terms used. So you can see mask, COVID-19, free, do online classes. I mean, so you can see the interest in the mask mandates and like the COVID-19, how it's affecting. And then this is the most used two-word phrases. So you see mask requirements, the mask again. You see the interest in food trucks again. You see the entry food, block party. You see mask is very, very high interest in food trucks. It also has a higher interest. So this is the most three-word phrases. You can see the food truck again. You can see also food. You can see the block party. You see food is a very, very, very interesting topic for them. So these are some of the examples of the tweets. You can see the hashtag essay. You see the essays again. So you see a lot of essays. So you need a lot of essay help. See the COVID-19. You see the block party, the food trucks, all examples of these keywords used. So this kind of shows the nature of the tweets. So you can see that 50% of the tweets was a happy nature and 44% of the tweets was a unhappy nature. And this is kind of more of the in-depth breakdown of the tweets of the nature of the tweets. You can see it kind of fluctuates back and forth throughout the semester from being more happy to more upset.
Collection 2 was collected from February 23rd, 2021 until March 24th, 2021. And the data collected consisted of hashtag WSSU tweets. And the total amount of tweets during this time period was 3,332. A timeline of the data collected, you can see that it kind of fluctuates a good amount between the time span. You can see it go up in late February and then go back down and then kind of go back up again in early March and then up again closer to the end of the timeline around March 22nd. Some spikes. The spikes in the tweets, I said that an increase could be for late February. This was students participating in challenges on Twitter, trying to get people to participate more and bring out like the college spirit since we were during the COVID and still trying to quarantine kind of. And then for early March 2021, that was when news of the CARES Act was being distributed and refund tweets were being seen. So you could see that there are more happy tweets than upset tweets during this time. And then in late March, the spike could be towards the anticipation of what graduation will look like, if it'll be in person, how many tickets. And then it also came from the previous class expressing their frustrations as to why that could be the reason for the upset and happy tweets, almost looking 50-50 when you look at the sentiment. The most used single keyword was help. And right after it was DM, and you can see essays and assignments. This leads you to believe that transitioning from traditional learning, like you're sitting in a classroom, to learning online through Zoom, you can see how students struggle a little bit more trying to get help with what they need and understand the material more. For the most two-word phrase, you see essay assignments, online classes, write essays, which kind of ties in with the one word, with students struggling in online classes with the transition, trying to stay on top of their work and maintain a social life as well. The most three-word phrase included essays, online classes, classes, science and math included DM. As you can see from the most used one-word phrase, two-word, and three-word, they all kind of correlate with each other. They all deal with helping with coursework, online essays, math, science. So you can kind of see a pattern here, and students looking for outside help after Zoom classes and trying to stay on top of their grades and do what they need to do. For examples of the most talked about topic on Twitter for the WSSU hashtag, you can see the Red Sea of Sound in Group 1, all the way down to Group 14, which talks about the CIAA for the men's and women's basketball team. You can see it talks about homework help again. You can see it talks about events going on, the CARES Act, Black History Month. You can just see a variety of things on the WSSU hashtag. And then for this time period, there were 52% of the tweets that were seen to be happy and 48% of the tweets that were seen to be upset. It was kind of 50-50 between both being happy and upset. So you could kind of see that they kind of balanced each other out throughout the timeline. And then this goes into more depth as to the days and how often people tweeted they were happy and upset. You can see that on the 14th, there were more happy tweets than upset tweets, which was because of graduation, refunds, all of that coming out. So you can kind of see that. But for the majority of it, you can see that it's kind of 50-50 between the two. Thank you for listening to our presentation. Now we will take any questions and concerns that you may have.
So again, I don't think we have any time for the questions. So we are going to move ahead with our last presenter, Charles Mickle. And then if we have time and if you want to hang out, then we can take some question and answer the questions over here. So Charles is a graduate student at Computer Science Department and also is doing his master's thesis.
Hello, everyone. My name is Charles Mickle of the Center for Applied Data Science. And this is my research presentation entitled Understanding Discharge Disposition in Acute Neurological Care, a machine learning-based approach. So before we get started, here's a quick overview of the research presentation. First, we're going to introduce the topic and the research, and then look a little bit at the background research and how our research differs from that, before stating our research question, and then showing our methods and our findings, followed by, of course, our conclusions and our future research intentions. As you may have gathered from the title of the presentation, our research considers the acute care setting and understanding patient discharge disposition. And the acute care setting is basically just an inpatient setting where patients receive care, usually for a severe type of injury. So now if a patient isn't discharged to the appropriate location, there could be several adverse consequences. And those might be receiving of inadequate care. They may fall or re-injure themselves. They could experience other negative health consequences. And ultimately, they could end up being readmitted to the hospital that they were recently discharged from. So our thinking was a predictive machine learning model based on that initial patient admission data could help doctors or even families better prepare for patient discharge. And our research considers over 6,000 patients from the eICU database, and only those admitted with acute neurological diagnoses, that is a stroke, basically. And our analysis of this data looks at several features, from patient demographics, as well as clinical variables and other medical risk determinations. So as I mentioned, our setting for the research is the acute care medical setting. And just a few of the differences from background literature that our research has is that it tends to focus exclusively on patients with stroke or cerebrovascular accidents. It looks only at patient data that's available either at or shortly after admission, within perhaps the first 24 hours. And it uses machine learning over traditional statistical models. And it tends to consider a wider range of patient features compared to the other literature on the topic. And the reasoning for machine learning is that it is a predictive analysis study with a large number of features, which is where machine learning can really shine. Our primary research question was, can the discharge disposition of a patient in that acute neurological setting be predicted with reasonable accuracy based on that early admission data? And our two discharge prediction targets were home and non-home. And non-home can include things like skilled nursing, rehab facility, nursing homes, another hospital, or other discharge dispositions. And the goals of our research were to basically find the highest accuracy model that can reliably predict discharge outcomes. And we had the goal that these models will be generalizable to similar early admission ICU data and usable in a suggestive context by medical professionals. And we also had a secondary goal of finding the features that are most important in the model's predictive analysis. Here's a little bit about the data we used. I mentioned it was part of the EICU Collaborative Research Database. The data was selected from 5 different tables in that database. And it includes features such as patient demographics, clinical variables, patient comorbidities, and Apache variables, resulting in over 36 columns with about 6,200 records. So here we have a descriptive table of our data. And looking at this, you can kind of get a better idea of how our data is distributed between the two target outcomes. For instance, if you look at the age row under patient demographics, you'll see the median age for home is 65, while the median age for non-home discharge is 73. And this can allow you to draw perhaps the intuitive conclusion that the younger a patient is, the more likely they are to be discharged to their home. And we do this kind of breakdown for every feature in the data. So here we have a quick overview of the machine learning models and methodology used. It was all done in Python or scikit-learn, but we did use the SMOTE library to offset the imbalanced data. So basically it allows you to scale up the target outcome with the lesser amount of rows to kind of balance the data out, allowing you to train a better model. And the models tested in this case were XGBoost, random forest, support vector machine, k-nearest neighbor, and logistic regression. So here we have the results for each of our model based upon 4 different evaluation metrics for both home and non-home. Those 4 metrics are precision and recall, which hopefully you're familiar with, as well as F1 score, which is basically a weighted mean of precision and recall, and the area under the ROC curve. And the primary takeaway you might have here is that they all performed pretty similarly in that 65 to 70% range, perhaps with the exception of K and N, which seemed to perform a little worse overall. So here we have our ROC curve analysis of all of our models. ROC curve basically just plots the true positive rate on the y-axis versus the false positive on the x-axis. And as mentioned before, you'll notice that our models all have a kind of similar curve here, with the exception of that K neighbors classifier model, which is substantially lower than the others. Here we have a feature importance graph, and this is basically how important our random forest model considered each feature to be in its analysis. The top 5 we'll look at, we have age, predicted hospital and ICU mortality, which are basically just Apache variables, doing what we described. And the day 1 verbal and day 1 eyes are Glasgow Coma Scale scores, which are typically used in a patient with head injury or stroke to show how well they respond with their speech or their eyes to things like verbal commands and other diagnostic tests. So to sum things up, out of the 5 models tested, our random forest, logistic regression, XGBoost, and the support vector machine all performed similarly at the 65 to 70% accuracy range. The KNN did perform slightly worse, about 5% lower overall. However, we do consider these to be significantly high accuracy results, considering the fact that these models did use features derived early on in the admissions process, within the first 24 hours. And the impact this research can have is that it could be used as a tool or suggestive model for these medical professionals to assist in making the most accurate discharge disposition determination. We also posit that it could be used for families to allow them to adequately prepare for the most likely discharge scenario of their family member. In the future, we hope to further optimize, tune, and improve our predictive models. And rather than simply looking at home versus non-home, we investigate this predictive modeling with more discharge disposition classes, examples being skilled nursing or rehabilitation facility. We also hope to include explainable AI, which can show which features the model weighed the most heavily and why exactly they did that. And ultimately, we hope to answer the question of, can these predictive models be used in practice by these medical professionals to improve patient quality of care, as that is the ultimate goal of the research. I'd like to acknowledge that this research was supported by the UNC Research Opportunities Initiative that was awarded to the Winston-Salem State University Center for Applied Data Science. Thank you all for observing my presentation, and I'll be happy to answer any questions you may have.
So thank you to all of our student presenters. I think they did a wonderful job. And if you, I know we are, over time already. So if you still hang out and would like to ask some questions, I think some of them student researchers are here to answer your question, or I am knowledgeable about each one of their projects, so I can probably take some questions as well. But again, thank you so much for all of our presenters and all of the faculty mentors for doing a fabulous job of preparing the students. And just like to say, if you want to visit us to our webpage link or our LinkedIn link, and here is our email address if you have many questions. So floor is now open to any question if you want to hang out and ask some question.